So let's start with the second part of this section, which is with example 18. So now with example 18, we need to find the polynomial function, and we have the zeros. They're telling you there are many correct answers. So what we're gonna do, these are two zeros. There's a theorem that says every time when you have the complex number is a zero, that means the conjugate also a zero. So we have three zeros here. That means x is going to be equal 4, and x equal 2i, and x equal negative 2i. Now let's bring back this one as a factors. So this one x minus 4, and this one is x minus 2i, and this one is x plus 2i. Now we need to find the polynomial function. That means f of x is going to be equal x minus 4, x minus 2i, and x plus 2i. You're gonna just FOIL it. I'm gonna FOIL these two parentheses first. So x times x is going to be x squared. X times 2i, so it's going to be 2ix. Negative 2i times x is going to be minus 2ix. Negative times negative is going to be negative. And negative times positive is going to be negative. 2 times 2 is going to be 4. And I times I is going to be I squared. Now let's simplify this one. We already know I squared equal negative 1. So this means f of x is going to be x minus 4. And here's x squared. Cancel these. Negative 4 times negative 1. That means f of x is going to be x times x. Let's write down this again before we start foiling. Here is x squared plus 4. Now we're going to FOIL these two parentheses to find the polynomial function. So x times x squared is going to be x cubed. X times 4 is going to be plus 4x. Negative 4 times x squared is going to be negative 4x squared. And negative 4 times 4 is going to be negative 16. We're just going to write down this because there is no like terms. That means the polynomial function is going to be x cubed minus 4x squared minus plus 4x minus 16. That's it for this example. So there is many type of solutions because the coefficient a here, we can assume that a is 1, 2, 3, and we're gonna get more than one solution. So you can put a here to find the polynomial. Here's a, and in this case, I'm going to let a equal 1. So that's why we're gonna put 1 and 1. If you put a 2, it's gonna be different. 3 is gonna be different, and keep going. That's why we have more than one solution. But if you type this one, it's going to be right. So x cubed, I don't know why I type capital X, x cubed minus 4x squared plus 4x minus 16. We're gonna do the same thing with the next example, but now we have 1, 2, 3 zeros. So example 19, we have 3 zeros. So we're gonna do exactly the same thing. Example 19. The zeros we have 9, 9, and 1 plus I. So we have 9, 9, and 1 plus I. This is a complex number. That means the conjugate 1 minus I also a 0. So in this case, this is x equal 9, and here is x equal 9, and here is x equal 1 plus I, And here is x equal 1 minus I. So here is going to be x minus 9, and here x minus 9, and here is going to be x minus 1 plus I, and here is going to be x minus 1 minus I. That means f of x is going to be, you can put the a, and then you can choose a equal 1, and it's going to be x minus 9, x minus 9, and here is going to be x minus 1 plus I, and here is going to be x minus 1 minus I. The next step, I'm going to let a equal 1. That means f of x is going to be just x minus 9, x minus 9, x minus 1 plus I, and x minus 1 minus I. Now, next step, which is going to FOIL. I'm going to FOIL these two, and I'm going to FOIL these together. Must mean f of x is going to be x times x is going to be x squared. X times 9 is going to be negative 9x, and negative 9x. Negative 9 times negative 9 is going to be plus AU1. Let's FOIL the second part. X times x is going to be x squared. X times this number, check what I'm going to write down, is going to be minus 1 minus I to the x. Then negative this number here times x is going to be also minus 1 plus I to the x. Then this one times this one. So it's going to be plus 1 plus I times 1 minus I. And we have to FOIL these two parentheses. Now, next step, f of x is going to be equal. Combine these together, the like terms here. So it's going to be x squared minus 18x plus 81. Here, I'm just going to simplify it. X squared, I'm going to distribute the negative sign with the x. So it's going to be negative 1x plus ix. Let's do this one on the side, because you're going to distribute the negative sign first. So it's going to be negative 1 plus I. Then you have to distribute the x, so it's going to be negative x plus ix. And that's why we get negative x plus ix. Negative x plus ix. And here is going to be the same thing, but minus 1 minus ix minus 1x. So minus 1x minus ix. Then we're done from this one. Here, what we're going to do, we're going to distribute these two parentheses. So plus 1 times 1 is going to be 1. 1 times I is going to be negative I. I times 1 is going to be plus I. And I times I minus I squared. So you have to be careful when you're working with numbers, when you're doing the math here. So f of x is going to be equal, here is x squared minus 18x plus 81. On this one is going to be negative x. No, you're not going to cancel this one. Ix cancels with negative ix. And negative I with positive I. So the left here is going to be x squared, negative x minus x, negative 2x. And what's the left here? 1 plus 1 minus I squared, which is negative 1. Let's simplify this one. So it's going to be x squared minus 18x plus 81. And here is going to be x squared minus 2x. Negative times negative positive. So it'll be 1 plus 1 is going to be 2. Until now, we didn't finish. We're just simplifying. We FOIL this part and we FOIL this part. Now we can FOIL these two trinomials. So f of x is going to be x times x, going to be x to the power 4. X times negative 2x is going to be negative 2x cubed. X squared times 2, so it will be plus 2x squared. We're done from the first number. Now the second one, we're going to multiply negative 18. So negative 18x times x squared is going to be negative 18x cubed. Negative 18 times negative 2 is going to be plus 36x squared. Negative 18 times 2 is going to be plus, it's going to be minus 36x. The last one is going to be distributing the number 81. 81 times x squared, so it will be plus 81 x squared. 81 times negative 2 is going to be minus 162x. 81 times 2 is going to be plus 162. Now we just have to combine the like terms. So f of x is going to be x to the power 4, which is this one. This is a cubed. This is a cubed. So combine these together. So it's going to be minus 20x cubed. Now this is squared. This is squared. And this is squared. So we have to combine these together. So it's going to be 81 and 36 and 2. It's going to be 119. Let's check that again. 81 plus 36 plus 2. Yeah, 119. So this one is going to be plus 119x squared. And for the x, we have 36 and 162. So 36 198. So this one is going to be minus 198x. And the last one is going to be plus 162. So this is the polynomial function for this example. Here we go, we got it right. Now let's go to example 20. With example 19, if we check here, we have a, and a equal, we're gonna let a equal 1. If you get a equal 2, you're gonna get different answer. If you get a equal 3, you're gonna get different answer. That's why they're telling you there are many correct answers. But if you look to example 20, 21 is the same, and 22 also. But example 20, degree 4, and we have 3 zeros, and we have the solution point f to the 0 equal negative 8. Let's check this example. So it's example 20. Example 20. So here's the information we have, the degree and the zeros. We have a complex number here as a 0. That means the negative 1 is also a 0. So in this case, here, negative I is also a 0. That means x equal negative 4, and x equal 1, and x equal I, and x equal negative I. That means here is going to be x plus 4, and x minus 1, and here is x minus I, and here is x plus I. Here is the zeros we have. Here, so f of x is going to be a. Here we have only one polynomial function. I'm going to tell you why. X plus 4, x minus 1, x minus I, and x plus I. We have one polynomial function. Why? Because we can find the value of a. They're telling you here f to the 0 equal -8. That means this is the y-intercept. If you have the y-intercept, you're going to plug in instead of each x 0 and to the negative f of 0 equal -8 to find the value of a. So in this case, if you have the value of the y-intercept, you can find the value of a. So let's plug in this point here to find the value of a. So I'm going to say f to the 0 equal a. Here is 0 plus 4, and here is 0 minus 1, 0 minus I, and 0 plus I. Simplify this one. F to the 0 equal -8. So here is -8 equal a. This is 4, and this is -1. This is -I, and this is I. Multiply everything here. So here is -8 equal, here is the a. -I times I is going to be -I squared. -I squared, which is equal -1. So it's going to be just 1. So this is 1. 1 times -1 is going to be -1 times 4, so it's going to be -4. Divide both sides by -4 to find the value of a. That means 2 is going to be equal a. So now we have the value of a. That's why we have only one polynomial function. We're going to go back here and plug in the a here to find the polynomial function. So f of x is going to be now 2 x plus 4, x minus 1, x minus I, and x plus I. This is the right solution. But now we need to simplify it. I'm going to foil these two, then distribute the 2 on everything. So f of x is going to be, here is the 2. X times x is going to be x squared. X times -x. 4 times x is going to be 4x. And 4 times -1 is going to be -4. Foil these two parentheses. X times x is going to be x squared. X times I is going to be ix. -I times x is going to be -ix. This is I. And -I times I is going to be -I squared. Simplify everything. So f of x is going to be 2 x squared. Combine these together, so plus 3x minus 4. And here is x squared. This is cancelled. -I squared, that means -1. So it's going to be plus 1. We're just simplifying. So f of x is going to be 2. Now I'm going to distribute everything here. So x squared times x squared is x to the power 4. X squared times 1 is going to be x squared. 3x times x squared is going to be plus 3x cubed. 3x times 1 is going to be plus 3x. -4 times x squared is going to be minus 4x squared. -4 times 1 is going to be minus 4. Let's simplify everything. Then the last step, we're going to distribute the 2. So here is x to the power 4 squared. 1 minus 4 is going to be, I'm going to write down the cubed first. So it's going to be minus 3x squared. And we have just this x, so plus 3x minus 4. Distribute the 2. That means f of x is going to be 2x to the power 4 plus 6x cubed minus 6x squared plus 6x minus 8. So this is the polynomial function with degree 4. That's what they're telling you, it's with degree 4. So we got the right solution. Now let's jump to example 21. This is different type of examples. They ask you to find all zeros and they give you the polynomial function and one of these zeros. So let's check how we're going to work on example 21. So 21, we have the polynomial function alpha of x equal x cubed minus x squared 25 plus 25x minus 25. And we have one of the zeros, x equal 5i. Yes, 5i. 5i is a complex number. So that's mean the other zeros, x equal negative 5i. So now I already know I have two zeros. I need to find the third one. What I'm going to do, always we're going to use the scientific division. I'm going to show you in the steps. Be careful with this example, because there's a lot of multiplication and there is an I. So every time when you have complex number, the conjugate also is going to be a 0. So let's use the scientific division with the first 0, with the 5i. There is no missing term, so 1, negative 1, 25, and negative 25. So here's the first number. 5i times 1 is going to be 5i. Now add these together, is going to be negative 1 plus 5i. Now we're going to multiply 5i times this one. This is the important thing. You have to be careful. I'm going to multiply it here on the side. 5i times negative 1 plus 5i. So 5i times negative 1 is going to be negative 5i. 5i times 5i, 5 times 5 is going to be 25. I times I is going to be I squared. That means it's going to be negative 5i. I squared is negative 1. So it's going to be minus 25. That means I'm going to write down here negative 5i minus 25. Combine these together. When you combine these together, 25 minus 25 is going to be 0. That means we're just going to get negative 5i. Then I'm going to multiply 5i times negative 5i. 5 times 5 is going to be negative 25. I times I is going to be I squared. I squared is negative 1. So it's going to be negative 25 times negative 1, which is equal to 25. That's mean I'm going to write down here 25. Add these together, it's going to be 0. That's mean this polynomial function, just so you're not get confused. This polynomial function is going to be alpha of x equal. This is the constant. This is x, and this is x squared. It's going to be k equal 5i. That's mean x minus 5i. This is the first factor, which is x minus 5i. And the rest here is going to be x squared plus negative 1 plus 5i to the x minus 5i. Now, if you look to this one, the second parenthesis is the quadratic. Yes, you're right. But you can't factor it. It's hard to factor this one. So what I'm going to do, I'm going to go back again and use the scientific division only on this part. So what I'm going to say, but I'm going to use the second. I'm going to use the second one. So the second zeros is negative 5i. I'm going to write down everything here because we already factored the first k, so keep it on the side. We're going to use the second k to find the left from this one, the other 0. So here is the first number. The second one is negative 1 plus 5i. And the third one is negative 5i. So write down the first number. Negative 5i times 1 is going to be negative 5i. Add these together. In this case, this one with this one is going to be 0. So the left is just negative 1. Now, negative 5i times negative 1 is going to be positive 5i. add these together is going to be 0. That means this is the constant and this is x. So I'm going to go back and write down this here. So f of x is going to be the first 0, which is x minus 5i. The second 0 is going to be from here, because here's k equal negative 5i. That means x plus 5i. This is the second 0. So x plus 5i. And the third 0 is going to be x minus 1. So we have 3 zeros on this one. Yes, we need to write down the x. So x equal 5i and x equal negative 5i and x equal 1. After we solve these, we're going to get the 3 zeros. And include the here enter your answer in comma, separate list, include the given zeros. So we're going to say 5i, comma, negative 5i, comma, and 1. That's it for this example. We're going to do exactly the same thing with the 22. So I'm going to keep example 22 for you because you're going to do exactly the same thing. Let's work on example 23. 23, we have a quadratic. So h of x is going to be x squared minus 6x plus 13. It's a quadratic, so I'm going to use the quadratic formula. I'm going to say a equal 1, b equal negative 6, and c equal 13. The formula x is going to be equal negative b plus or minus square root of b squared minus 4 times a times c, and everything divided by 2a. So x is going to be equal negative b, that means negative negative 6, plus or minus square root of negative 6 squared minus 4 times 1 times 13. And everything is divided by 2 times 1. That means x is going to be equal 6 plus or minus square root of negative 6 squared is going to be 36. 4 times 1 times 13 is going to be minus 52. Everything is divided by 2. And this one is going to be equal 6 plus or minus square root of negative 16 divided by 2. Now simplify everything here. The negative sign and the even root is going to be I. Square root of 16 is going to be 4. That means x is going to be equal 6 plus or minus 4i. Everything divided by 2. Now we can simplify it. So x, 6 divided over 2 plus or minus 4i divided by 2. That means x is going to be 3 plus or minus 2i. That means we have 2 zeros. We have x equal 3 plus 2i, and we have x equal 3 minus 2i. So to write down the first option, they're telling you write down the polynomial function. What they ask you? Write the polynomial as a product of linear factor. We need to write down the polynomial as a product of linear factor. So the first factor here, move back this one, is x minus 3 plus 2i. 3 plus 2i. This is the first factor. And here is x minus 3 minus 2i. So here is the two factors. That means we can write down f of x equal x minus 3 plus 2i and times x minus 3 minus 2i. So here is the two factors for this polynomial, we're just going to type these here. So 2 parentheses, we're going to say x. So here we go. We got it right. And the next part, we're just going to write down the zeros, list all zeros. We got it from here, which is 3 plus 2i, comma, and 3 minus 2i. These where we got the zeros. That's it for this example. Let's work on example 25. You're going to do always the same steps on example 25, 26, and 27. 25, here's the example. The first thing we need to find all possible zeros. So a naught equal 4, equal 2, and an equal 4. That's mean P is going to be the factors of a naught, which is plus or minus 1, plus or minus 2. And Q is going to be the factors of an, which is plus or minus 1, plus or minus 2. Write down this here. It's easier to find these possible zeros. Plus or minus 1, plus or minus 2, and plus or minus 4, because you're going to divide. So P over Q, the possible zeros is going to be 1 by 1 is going to be plus or minus 1. 1 by 2 is going to be plus or minus 1 over 2. 1 by 4 is going to be plus or minus 1 over 4. 2 by 1 is going to be 2, so plus or minus 2. 2 over 2 is going to be 1. 2 over 4 is going to be half, which is already we have half. So these are the possible zeros. Now let's start with the first k equal 1, then k equal negative 1. Then I'm going to drop k2 and negative 2 before I start working with these fractions and check if it's work. Then I'm gonna work with this fraction if it's not. So let's start with k equal 1. K equal 1, there is no missing term. So I'm gonna say here's 4, 9, 6, 9, 2. And here's 1, it's going to be 4. 1 times 4 is going to be 4. This is 13. 1 times 13 is going to be 13. And here's 19. 1 times 19 is going to be 19. Add these together is going to be 28. 1 times 28 is going to be 28. Add these together is going to be 30. Reminder not equal 0. So we're going to go to k equal negative 1. Do the same steps. K equal negative 1. So here it's going to be 4, 9, 6, 9, 2. So here is 4. It's going to be negative 4. Add these together is going to be 5. And here, negative 1 times 5 is going to be negative 5. Add these together is going to be 1. Negative 1 times 1 is going to be negative 1. Add these together is going to be 8. Negative 1 times 8 is going to be negative 8. And the result is going to be negative 6. Also, the remainder is not 0. So I'm not going to choose these two. Okay. Let's go. I'm going to start with the 2. So when k equal 2, when k equal 2, here's 4, 9, 6, 9, 2. So this is 4. Multiply is going to be 8. Add these together is going to be 15. 2 times 15 is going to be 30. Add these together is going to be 36. Multiply 2 times 36 is going to be 72. Add these together is going to be 81. Multiply these is going to be 164. Add these together, 162 is going to be 164. And again, the remainder is not 0, so I'm not going to choose k equal 2. What about k equal -2? I'm just choosing. You don't have to choose these numbers first. You can keep going by the half, because you have to keep trying. Half, then negative half, then -1/4, 1/4, and keep going the same thing. I'm choosing these because these are whole numbers, and it's easier to work on it. 4, 9, 6, 9, 2, because you have to try all these possibles. So here's 4, it's going to be -8. Now this is, add these together, 1. -2 times 1 is going to be -2. Add these together is going to be 4. -2 times 4 is going to be -8. Add these together is going to be 1. Now -2 times 1 is going to be -2. Add these together is going to be 0. So the first zeros is kx plus 2. X plus 2. Now that means our polynomial function is going to be x plus 2, and this is constant, x squared, and x cubed. On the left is going to be x cubed plus x squared plus 4x cubed plus 1. Constant is 1. So we're done from the first part. Now, because we need to find all zeros, that means I need to go back and do the same thing here. Sometimes you have to try to use the same number here, the same zeros on this part. If it's work, that means this one is going to be squared. So let's try here. If not, we're gonna use the same number with the left over here. So -2, I'm gonna say 4. Sometimes it's work. That means this one is going to be squared. Sometimes it's not. So here is 4. Multiply here is going to be -8. It's going to be -7. Then multiply -2 times -7 is going to be 14. Add these together is going to be 18. Multiply here is going to be -2 times 18 is going to be -36. Add these together is going to be -35. This is not 0. That means it's not going to work. So we have to go back here and use the same b's but different zeros. Let's keep going on this example. Then I'm going to use now k equal -1/4. I'll use the positive first. If it's not going to work, I'm going to go to the negative. If it's not, I'm going to go to the 1/2. If it's not, I'm going to go to the -1/2. So I'm going to use 1/4 only on this part. So 1/4, and here is 4, 1, 4, 1. So here is 4. 1/4 times 4 is going to be 1. Add these together is going to be 2. 1/4 times 2, 1/4 times 2 is going to be half. Add these together, that means 4 plus half. I'm going to put this one over 1, multiply by 2, multiply by 2, so it's going to be 8/2 plus half is going to be 9/2. So it's going to be 9/2. Now 1/4 times 9/2, 9/2 times 1/4, so it's going to be 9/8. Add to the 1, 9/8. Add to the 1, that's mean this one is going to be 8/8. So it's going to be 17/8. which is not equal 0. So I'm not going to use this one. I'm going to use k equal -1, 4. And let's see. 4, 1, 4, and 1. So -1/4. So here is 4. Multiply these. It's going to be -1. Add these, it's going to be 0. -1 4 times 0 is going to be 0. Add these, is going to be 4. -1 4 times 4 is going to be -1. Add these, is going to be 0. That's mean this part is going to be, this is constant, and here is x, and here is x squared. That means alpha for the x is going to be x plus 2, and here the k from here is going to be x plus 1/4, x plus 1/4, and this is the constant, this is x squared, so 4x squared plus 4, and that's it. To find the zeros, because they ask you to find all real zeros, for example, 25, yes. So we're going to solve this one. So x plus 2 equals 0. That means x equals -2. X plus 1/4 equals 0. So x is going to be -1/4. And 4x squared plus 4 equals 0. That means 4x squared equals -4. Divide both sides by 4. So x squared equals -1. Take the square root for both sides. So x is going to be plus or minus the square root of -1 is going to be I. That means we have x equals -2, x equals -1/4, and x equals I, and x equals -I. So we have 4 zeros for this example. Let's check, not this one, example 25. So I, comma, -I, comma, and -2, comma, 1/4. -1/4. That's it for this example. You're going to do the same thing for example 23, 24, and 27, 26, and 27. The same techniques how to find the zeros.